Okay, good afternoon everyone, and welcome to today's Enviro talk on Eurofin's new QToF Discovery suite of testing. On behalf of Eurofins, we acknowledge the traditional custodians of the lands we're meeting from today. For me and my family, where we have been living in since arriving in Australia in 2017, it is the Wurundjeri people of the Kulin Nation here in Melbourne. We pay our respects to their elders past and present for their cultural heritage, connection and law with the land and waters where we work and live. We'd also like to acknowledge and pay our respects to any Aboriginal and Torres Strait Islander peoples joining us today. On to housekeeping. Today's presentation will take approximately 40 minutes and we'll be allowing around 15 minutes for Q&A at the end. During the presentation, if you have any questions, please feel free to put them onto the chat function within MS Teams. Kathleen Wrigglesworth, our marketing manager, will be facilitating the Q&A session at the end. This webinar is recorded and will be distributed to those that have registered, including the slides from today's presentation. My name is Shazy. I'm the General Manager for Eurofin Specialty Services, overseeing our water markets, microplastics testing lab, mold testing lab, air toxics lab, dioxins and furans lab, as well as our emerging contaminants lab. Our Emerging Contaminants Lab is largely run by Dr Amy Heffernan. Dr Amy Heffernan is a technical specialist with Eurofins Australia New Zealand and is based in our Brisbane lab. Amy has a PhD in environmental chemistry from the University of Queensland and 15 years experience in analytical chemistry method development, including high-resolution mass spectrometry. Amy specialises in contaminants of emerging concern, including microplastics, PFAS, organophosphate and brominated flame retardants, and extractable and leachable compounds. Amy has more than 40 research publications, and much of this research has been used to inform national policy. I will now hand over to Dr. Amy, who will kick us off with the presentation. Amy?
Hello everyone, thanks for the introduction, Shay. Before we begin, I would also like to acknowledge the First Nations people as the traditional owners of the land on which I am today, which is Meanjin in Brisbane. I recognise the country north and south of the Brisbane River as the home of both the Turrbal and Yagara nations. I pay deep respects to all elders past, present and future. So today I'm very excited to present to all of you the QToF Discovery Suite, which is a project that I've been working on for several months now. As Shay mentioned, I do fall under the Emerging Contaminants Laboratory and more broadly Specialty Services Lab, but I like to say that anything weird and wonderful you can send my way and I will do my very best to help you out. So before we get started, I just wanted to give you a brief agenda for the webinar today. Following the introductions, I will walk you through the alphabet soup and some of the jargon that I'll be using throughout this talk. I will try to keep that to a minimum, but I want to make sure that we can all follow along on the journey. Then I'll present to you the Discovery Suite itself and finish up with some example case studies from the work that we've done, followed by the Q&A session. So I guess the main thing that I wanted all of you to be able to get out of the webinar today is to understand this new tool that myself and my team have developed as being an extra tool or an extra option for you for your regular site investigations and client work. So I'm going to use PFAS as an example throughout this talk. What I discuss herein is not restricted to PFAS by any means. I'm just using it because I think it's fairly safe to say that most of us are at least familiar with PFAS. So I will use that as a bit of a jumping off point. So speaking of, if we think about PFAS as an example, we know that there are lots of different standard tests available to measure PFAS in different ways. So we have combustion ion chromatography for total organic fluorine. We have the TOP assay for precursor analysis, and then targeted analysis via LC triple quad mass spec, and of course many others. But what I'm going to be discussing today is specifically non-targeted analysis using high resolution mass spectrometry. So that leads me straight into alphabet soup. Now, I'm going to talk through two main concepts. The first of these is targeted analysis versus non-targeted analysis. So what those two terms mean and the differences between them. And then the same thing for high resolution mass spectrometry versus unit resolution mass spectrometry. And then I'll explain to you why this matters. So it's going to be a very high level overview. I'm not going to do a deep dive into the chemistry of these. If you're interested, by all means, it's one of my favorite topics. But let's keep things nice and light for a Thursday afternoon. All right, so starting off with the concept of targeted versus non-targeted analysis. So this really refers to the experimental design, or more specifically, the mode in which we collect data. So when I say we, that is myself and chemists in the laboratory. And a targeted or a non-targeted experiment can be achieved with lots of different types of instrumentation and equipment. So I'm going to do my best now to explain this concept using a fishing analogy, which may not have been the best choice because I don't know anything about fishing, but let's see how we go. So when we're talking about targeted analysis, this is what you would be very familiar with for your standard suites when you submit a soil or a water sample to Eurofins. So targeted analysis would be your request for PFAS in water. It would be your BTECs, your PAHs, and so on. In very simple terms, what it means is you know what it is that you're looking for, and we're going to use special bait or special methods to catch your target. So if I use this fishing metaphor, we know that we're looking for red fish out of all, so the fish represent all the possible components of your sample. I know that I'm looking to identify the red fish, so I'm going to use a red worm to catch the red fish. For non-targeted analysis, this works very differently. So I'm going to swap out my fishing boat for a fishing trawler, because now I'm actually going to try and capture every single fish in the ocean, which is horrible from an environmental point of view, but just bear with me. So you can imagine that it's not possible for any technique to measure every single thing. Every piece of equipment, every analysis has its limitations. So there are going to be a few fish that do escape. But for the most part, we're going to try and measure or capture as many fish as possible. So after we've been out on our fishing expedition, we're going to have very different results. So in our targeted analysis, we're only going to have our red fish. So typically there might only be very few of these, and we know that we were setting out to catch red fish in the first place, and we have a special red ruler so that I can measure the size of my red fish. With a non-targeted analysis, I have many fish as my boat can carry. And because there are so many of them, this is a very complicated situation. So it's a very large data set, a complex data set. The fish are unknown, so I don't know what color they are, which means I don't know what standards or what ruler I'm going to use to measure them. So how do we go about measuring these fish or characterizing the compounds following a non-targeted analysis? So the way that we do that is using a technique. This is a data processing technique now. So the fishing trawler is my data collection. The suspect screening is now my data processing. So suspect screening or known unknowns, these two terms can be used interchangeably. And basically it's a bit like a shopping list or a checklist. So I'm going to have my list and I'm going to check, do I have a red fish? Yes or no? A blue fish, a green fish, and so on and so on. And depending on what's on this list, that will determine what you're able to identify or not in your non-targeted analysis. So just keep this in mind, the fishing trawler and the checklist concept, and I'm going to come back to that in a moment. All right, so let's talk now about high resolution versus unit resolution mass spectrometry. So this is really referring to the analytical instrumentation in the laboratory. And of course, this comes in lots of different varieties. But again, speaking very broadly, we can say that any analytical system consists generally of two parts. The first part is the separation part. So that might be LC or liquid chromatography. It might be GC, gas chromatography, or it might be something else. So we have our separation component. And then the second part is the measurement component. So in these examples, we have two different types of mass spectrometry. For what I'm talking about today, the separation component doesn't matter at all. There are other ways of measuring, of course, aside from mass spectrometry, but because MS is what we use for the QToF Discovery Suite, I'm going to focus on that today. So let's ignore the separation and focus on the mass spectrometry. So two different systems, both of them are mass spectrometers. The difference is one is high resolution and the other is unit resolution. So some people call unit resolution low resolution. I think that's a bit mean. It makes the instrument sound like it's less than, and it's definitely not. It is a very, very valuable tool. So I'm going to call this unit resolution instead. So on the left, we have just an example of a high resolution system. So this is an LC QToF. QToF is quadrupole time of flight. The TOF, time of flight part, comes from, if you see the chimney sticking up there, that's called the flight tube. My animation was flashed up very quickly there. I'm not sure if you caught it, but it also refers to the path that the compounds take through the instrument. So instead of traveling in a straight line from one end to the other, they actually go up to the top of the chimney and back down again. So this is different to the system on the right, which is a unit resolution system. And this example is a LC triple quad or triple quadrupole mass spectrometer. So again, if I go back to my PFAS example, an LC triple quad is the system that is used for your PFAS analysis. So why am I talking about this? The high resolution system, such as a QToF, is essential for non-targeted analysis, and I'm going to show you why. So on the right-hand side, this molecule here, this is PFBA. So I know what this compound is. If I measure it with my unit resolution system, so I know this is PFBA. I know what the mass is. It's 213.9. Now, if I was to check this mass against my checklist from my non-targeted analysis, I would end up with over 6,000 different results. So in amongst that list of 6,409 compounds, PFBA would be one of those entries. But you can imagine I only have a 1 in 6,000 odd chance of actually selecting the correct compound. So if I take the same sample and instead I'm going to put it through my high resolution system now, my QToF, we're able, inherently a QToF system or a high resolution system is able to measure that mass much more accurately. So compared to a triple quad where I get 213.9 with 1 decimal place, now I have 213.9865 with 4 decimal places. And again, the reason this matters is that when I compare my data to my checklist, I'm able to decrease the number of hits from 6 odd thousand down to 18. So as the mass error of the system increases, as the mass error of the system improves or it decreases, it means that I'm able to narrow down the results much more effectively. And this is really essential for compound identification. And again, the reason for this is we don't necessarily have standards available or certified reference materials available for all of the fish in the sea because there's so many of them, and we only have finite amounts of money. So if we don't have standards available, how is it that we identify these fish or identify these compounds? I'm going to show you another PFAS example now. So let's pretend for a second that I'm analysing this compound. It is ethyl fosa. I'm analysing this compound with my unit resolution system. In this instance, I'm able to measure my peak. I have the retention time, and the area under that peak is proportional to the concentration, and I can compare that to my reference material, and that's how I'm able to give you a quantitative result. Now again, let's analyse the same sample on a QToF system. So I'm still able to see the same peak, but this time I'm able to get information on the accurate mass. So that's measuring that mass to 4 decimal places. I can then compare that to the theoretical mass and get an indication of the mass error. And the smaller the mass error is, the more likely it is that the compound is what I think it is. Then I get some more information. So this is real data. What I can see from this data is an indication of the isotope profile or isotope pattern of this compound. I can look at the ratio between different peaks. So this might be, for example, comparing chlorine 35 and chlorine 37 peaks, or any sort of naturally occurring isotopes. I can compare the predicted elemental composition or the formula of the compound to my experimental data. And then based on that data, I can then predict the formula, and the strength of that prediction is given a score out of 100. So what you can see in the example here is just a mirror plot. On the top in blue is the experimental data. So this is what I'm actually measuring in my sample. And on the bottom is what I would expect to get if this compound is indeed my ethyl fosa. But that's not all, folks. We still have even more information that we can get out of our high resolution system. So now I can look at the fragmentation pattern of my compound, and the best analogy that I can use for this is the fragmentation pattern is a bit like a chemical fingerprint. So I can match my chemical fingerprint against my checklist, which also contains lots and lots of different chemical fingerprints for different compounds. Again, on the top, I've got my experimental data. On the bottom is my checklist or my library or my database chemical fingerprint, and the strength of that match, I get another score. So then I take all of that information and combine it, and this gives me an indication of the strength of the match. So just to wrap all of that up, I know that was a lot of information in a short amount of time. I'm combining here my high resolution mass spectrometry, that's my QToF. I'm doing a non-targeted analysis, so I'm trying to capture as many fish or as many compounds as I possibly can from my sample. And then I'm going to take that data and do a suspect screen against my suspect list or my reference database. Now we have lots of different databases available, and that ranges from small databases that we have created ourselves, such as the first one in this table here. So this is an in-house PFAS library that we have created from authentic materials. So we collect the chemical fingerprint, and then we can use that information to apply to other samples. And then we also have different databases that are curated for different purposes. So you can see there we have options for environmental waters, for pesticides, veterinary drugs. And then these databases can grow to become very, very large. So you can see at the bottom there, PubChem and ChemSpider, these are publicly accessible databases, have got millions and millions of compounds in them. So you can imagine that trying to search a large amount of data against a very large database can be quite an arduous task. But we have a number of tools available to us that help us to do that comparison. And these tools are how we're able to actually give you a result without necessarily having a reference standard available. All right, so let's just examine that for a moment, because one of the questions that I get quite a lot is, can you give quantitative data from a QToF analysis? The answer is sometimes. So let's first talk about the best case scenario. So you'll have to forgive my drawing skills here, but this is a kitchen scale. And you can imagine this is a certified reference material. And I'm going to be collecting different pieces of evidence. And the weight of evidence is going to give me the certainty or the confidence in my compound identification. So if I have a certified reference material available, that's the best case scenario. That means I have unequivocal compound ID. I am absolutely 100% sure that my PFOS is my PFOS. So this is what we call gold standard, and this is what is used in the targeted analyses, so the standard suites that Eurofins offers. As I've said, with QToF analysis, we don't necessarily have standards available. Sometimes we do, but most of the time we don't. So instead, what we have to do is collect multiple lines of evidence. So we're able to measure the accurate mass. We have information on the isotope profile, the chemical formula, the fragmentation pattern, and the library match. So while all of these lines of evidence together don't quite add up to be the same as an unequivocal identification, it does give us what we call a tentative identification. And the way that this is communicated to you, the client, and in fact communicated on the report that you would receive, is as a confidence level. So this is a 5-level scale. It was developed by Professor Emma Szymanski, and this has been largely adopted by the high-resolution mass spec community, starting in the research space, but now moving more into commercial areas. So at the top of the pyramid, we have a level 1 identification. So this is our unequivocal ID. This is if I have a standard available. So as I said, most of the time we don't have this. What we can give you though is a level 2 or a level 3 identification. And this depends on that weight of evidence that I was speaking about earlier. So depending on the different lines of evidence that we've collected, how good those matching scores are, that will determine whether it's a level 2 or a level 3 identification. So a level 4 and a level 5 are possible. but in my opinion, it's not of much use outside of the research space. So the products that I'm talking to you about today are going to fit mainly in this level 2, level 3 area. Okay, so that's all of the theory. And I wanted to go through this so that you can, I guess, for me to provide some context to help you understand the products which I'm about to describe to you, and then also some case studies matched to each. So the QToF Discovery Suite itself consists of 5 different products using a combination of LC QToF and GC QToF, depending on the application. The first 2 products, and by far this is probably our most popular request, are based around PFAS and PFAS characterization. So the first of these produces what's called a compact report, and the second you would receive a comprehensive report. So let me show you what that looks like. In a compact report, you will receive a report that looks like this. So it's a presence-absence test for around 100 PFAS compounds. So this includes, you know, our legacy compounds as well as precursors and, you know, all different components of the PFAS family. And these are all tentative identifications to a level 2. So compare that to if we were to take the next step and request a comprehensive PFAS characterization, you get the same presence-absence report, but on top of that, you get more information about the chemical fingerprint, or more specifically, the PFAS fingerprint of your sample, as well as an interpretive report to help you understand the results. And the situations where this test has been most requested are generally trying to identify AFFF sources. For example, if there's been a spill or legacy activity on a site. For example, this is some real data from an AFFF impacted site. So we had received both soil and water samples, and the brief for the project was trying to understand which AFFF formulation had been used. So based on the information we collected from this sample, we were able to identify a very strong signal for PFOS, as well as a bunch of other PFAS. But combined with a little bit of expertise from our PFAS chemists, we can start to tease apart this chemical fingerprint to understand which AFFF was used. So for example, we know the dates from which PFOS was the main ingredient and what products were manufactured with it. There's a notable absence of fluorotelenosulfonates, so this excludes formulations that were based on that, such as Ansilite. And again, based on this chemical profile, we were able to match this to historical PFOS mil-spec AFFF formulations. And so in this instance, our suggestion to the client was that this was a 3M light water chemical signature. All right, so moving from that, which is quite complex, to the simplest test in the QToF Discovery Suite. This is product verification. So this one is quite simple. An example would be you would send us a product. For example, it might be a bottle of Roundup, and we know that the main ingredient in Roundup is glyphosate. And you would say, Amy, can you tell me if there is glyphosate in this sample? Aside from reading the label, I would actually test this sample for you. And I could determine, for example, the active ingredients in a pesticide formulation. It might be the active ingredients in a pharmaceutical product. It might be a contaminant in a water sample. But in this instance, for this test, I define beforehand a small number of components that you want me to look for. So instead of using a very large database, I would have 3 or 4 components that the client specifies beforehand, and I can tell you yes or no, is this compound in my sample? All right, then next up is the contaminant screen. This is used for, can be used on any sample type. So soil and water are, of course, the most popular, but we can do lots of other sample types. The most popular request is based on wastewater, influent, effluent, or sewage outfall pipes, that type of thing. And this contaminant screen, we use a database that contains a number of components focused mainly on pharmaceuticals and personal care products, pesticides, and drugs. And then our final product is called environmental forensics. And this is basically the last stop. It is the most complex test in this analytical suite. And I would recommend this for the most complicated types of analyses where maybe the other 4 types of tests that I've discussed, they haven't worked, or we haven't been able to come up with a solution for you. So on the top right there is an example of a sample that we received. And it might be a little bit small, but if you can see that, that white powdery residue on the leaf litter, we were asked to identify what that was. So in this instance, we have no idea what we're looking at. We can try and analyze it with our QToFs. Maybe that works, maybe it doesn't. So we use the kitchen sink approach, or where basically we throw everything we can at your sample until we can get a result. As I said, this is quite complex. It can be like looking for not just a needle in a haystack, but more like a needle in a needle stack, because we don't know what it is that we're looking for or what the impact of that mystery compound might be. So an example of this type of approach, this was a story or a situation that actually hit the media at the end of last year. So there was a small creek in Brisbane that turned bright blue, as you can see there. So we received a sample of this water. There was also, so aside from the colour change in the creek, there was an associated fish kill. And we were tasked with identifying, could we identify what the causative agent was? So through a range of different approaches, we were able to actually identify a very strong signal from an optical brightener that's used in commercial laundry detergents. And so it just so turns out that there is a manufacturer of said detergent upstream, and there was a release from their site to the local waterway. So this was a really nice example of the QToF Discovery Suite actually achieving a clear answer for our client. So we have a couple of different statistical tools that we can also use for very complex investigations, and these include things like principal component analysis, Kendrick mass defect filtering. And just quickly, I have one last example one last case study to walk through with you. So we received some samples of these IV bags. Now the client was testing out different types of labels. So normally there would be a pharmaceutical inside the bag, and they were seeing a decrease in the efficacy of the drug when they applied different labels, and they wanted to know what was causing it and if it was in fact attributable to the label. So for this particular sample, we used what's called a comparative screening approach. So we were looking for chemical fingerprints under 3 different scenarios and trying to find those 1 or 2 components that were actually interacting with the drug. So we used the approach that I outlined earlier, comparing our experimental and our reference chemical fingerprints. We then sent this to the client, and they came back and said, well, can you tell us exactly how much of this compound is present in our sample? So for this, we went to the second stage. We actually went out and purchased a reference material. and we're able to give not just a tentative identification, but a unequivocal identification of this 2-ethylhexanol, which was the contaminant, and it's a component in the adhesive used in only one type of label. So obviously they chose not to use that one. All right, so it's been a bit of a whirlwind, but I hope that what I've been able to show you so far is that the combination of high resolution mass spectrometry and non-targeted analysis can be used for a range of different purposes. So it can be used as an additional tool, or when you need to go beyond the standard test suites that are available. It can be used for unknown compound identification, including when there are no reference materials available. It's particularly useful for complex samples and/or complex projects, and it does enable retrospective data analysis. So we can go back and look at, we can go back and interrogate the data days, weeks, months, or years after the fact to identify, for example, emerging contaminants or investigate legacy contamination. And so before I finish up, I wanted to leave you with a question, and that is, what else can we do for you? So if you come up, if you have an idea or come up with a question that you think this QToF Discovery Suite might be able to help you, please reach out to me. I want to create these products to be useful for you, so I am definitely relying on your feedback for that. And now I will leave you with my contact details and pass over to Kathleen to facilitate the Q&A.
Thank you, Amy, so much for simplifying what is a very, very complex topic and making it a little bit easier for all of us to understand. There's no questions in the chat at the moment, but if anyone's been sitting on anything, just pop it in the chat now. The recording of this webinar will be made available in coming days, and it will also include Amy's contact details in that correspondence. So if you think of anything in the meantime and want to get in touch with Amy, we will provide her contact details to you then. Doesn't look like anyone's got any questions, so you must have explained that perfectly. Thanks, Amy. Yeah, thank you everybody for attending. Yeah, we will send out the link to the webinar if you want to share it with your colleagues or watch it again at any stage. Oh, hang on, someone's typing a question. Feel free to do so. And please get in touch if you're interested in the QToF Discovery Suite at all. Someone's typing a question. Nope, doesn't look like it. All right, if no one's got any questions, we'll close that off. Thank you so much for your time, Amy. It was a wonderful presentation. And yeah, we'll be in touch with everybody to follow up in the coming days. Thanks, Amy.
Thank you, everyone.